Today we'll be doing the indefinite integral of the natural log of x divided by 1 plus x dx. And to start off, we will use integration by parts. So we'll let u equal the natural log of x, which means that du equals 1 over x dx. We will let dv equal 1 over 1 plus x, which this means that v equals the integral of 1 over 1 plus x dx, which will end up being the natural log of 1 plus x. So using the integration by parts, we have the natural log of x times the natural log of x plus 1 minus the integral of the natural log of 1 plus x over x dx. And we will use the series representation of the natural log, and we have that the natural log of 1 plus x is equal to the sum from 1 to infinity, negative 1 to the k minus 1, x to the k over k. So we have a natural log of x times the natural log of x plus 1 minus the integral of 1 over x. And then replacing the natural log with the sum, we have the sum from 1 to infinity, negative 1 to the k minus 1, x to the k over k dx. And then swapping the sum and integral, we have the natural log of x times the natural log of x plus 1, and then minus the sum from 1 to infinity, negative 1 to the k minus 1 over k, and the integral of x to the k over x will end up being x to the k minus 1 times dx. So evaluating the secondary integral, we will have the natural log of x times the natural log of x plus 1 minus the sum from 1 to infinity, negative 1 to the k minus 1 over k, and that's going to be a x to the k over k plus a constant of integration. Combining the k's, we have the natural log of x times the natural log of x plus 1 minus the sum from 1 to infinity. And while we're at it, we will decompose the negative 1 to the k minus 1 term. So we could write this as negative 1 to the k times negative 1 to the negative 1, x to the k over k squared plus c. But as you notice, we could cancel these negatives into a positive. And we have the following: the natural log of x times the natural log of x plus 1 plus the sum from 1 to infinity. We can combine the negative 1 to the k and x to the k as negative x to the k over k squared plus the constant of integration. And we'll notice that the dilogarithm of u is defined to be the sum from 1 to infinity of u to the k over k squared. So this means that the dilogarithm of negative x will be the sum from 1 to infinity of negative x to the k over k squared, which is exactly the sum we're looking for. So now we have that, therefore, the integral of the natural log of x over x plus 1 dx is the natural log of x times the natural log of x plus 1, and then plus the dilogarithm of negative x plus the constant of integration. And so this is the final result. Thank you very much for watching.